Okay, so here's problem 41. And they show you the three graphs, A, B, and C, and you have to figure out which one's f of x, which one's f prime of x, and which one's f double prime of x. And I'm just going to tell you a good rule of thumb is a question like this. As a best guess, assume that the simplest looking graph is f of x. And I've drawn that in here, that's A. And I think you'll see why that is. It may not always be true, but it's a good first guess. You can always double check, make sure you're right. But let's assume that A is f of x. So y equals f of x, that's what we've got drawn in here so far. And we're looking for f prime of x. And remember, f prime of x, another notation for that is simply dy over dx. And this is useful because it just reminds us that the derivative is a ratio. Remember, it's change of y over change of x as the limit as x goes to 0. So it's a ratio, which means that's why it's the slope of the tangent of any tangent line, or it is the derivative at any point is the slope of the tangent line at that point. And the right-hand side reminds us that it's a function of x. So in many cases, or most cases, it's going to change. It's going to vary as x varies. So how does dy dx vary in this graph of A? Well, we can see that it's positive down here, and it increases in value. Right around here is where it looks to me like the slope reaches a maximum. Actually, I haven't drawn this very well. Looking back at the problem, the slope seems like it reaches a maximum right around here. So that's a crucial point. And then it decreases but remains positive until here, and then it finally gets into the negative range here. So we can think of this top of the hill as a maximum, and when f of x is at a maximum, that's where the slope is 0. So the derivative is going to be 0 where there's a maximum. Okay, so with those sort of key points in mind, we can sketch out f prime of x. So it starts out here on the left positive, somewhere not very high, but still in the positive range. And we said it's going to increase and reach a maximum here. And it's going to drop down to 0 here. So it comes down, and from here on it's going to go into the negative range. So this is B. So yeah, so we've just sketched it out, and we can see that it looks very much like B, so we can be sure that we're on the right track. Now let's just repeat that procedure for graph B. So f prime of x is now the function that we're looking at, and we want to find the derivative of that, f double prime of x. Okay, well, here it's positive over on the left-hand side, so it, just like f prime of x, it's going to start out sort of in the low positive range, and it steadily increases. Here's kind of the maximum for f prime of x, the maximum, not the maximum value, but the maximum slope. This is where f double prime reaches a maximum. F double prime is going to reach a maximum here. Here we reach a maximum of f prime of x, and that means that the slope of f double prime is going to be 0 up here. So at this point, f double prime is going to be down at 0. And then f prime of x becomes negative all through here. So after this point, it's going to be negative. Actually it's going to come down, because here's where it reaches a maximum negative slope. So it's actually, and then it gradually becomes less negative. So It's actually going to come down like this, I think. Again, I'm just sketching it out. I may have made some mistakes, but you get the general idea. So going back, this is f double prime of x. It reaches a maximum right around here, and then it comes down, and it reaches a minimum, then comes back up, although it remains negative. So now that's kind of like C. As I look at C, I probably didn't draw it very well. This should be kind of a deeper minimum. That's C. So that's the answer. And you can explain your choices. Obviously, I took a lot of words to explain my choices, but maybe you could condense that into a shorter number of words. But let's just double check our answer. Whoops. Let me do this. Let me go to a new page. What if we had chosen C as our f of x? What if we said, okay, I think it's C? Well, let's kind of sketch out C. Whoops, don't like that. Sketch it out more like. There we go. Well, let's see if I can erase this. There we go, good enough. Oops. I think you can see that well, let's just do it. Okay, let's say we want to take dy dx of this graph, f prime of x. Well, it would start out positive, but sort of low positive. It would reach a maximum here. It would reach 0 here. So it's down to 0 here. And it's negative all the way down to here. Reaches sort of maximum negativity here. That's where the slope of f of x is greatest in the negative range. So it comes way down here. The slope is 0 down here at this minimum, so it has to go back up to 0. And then it's positive the rest of the way, but sort of decreasing positive. So this is, if C is f of x, then this graph would have to be f prime of x. But there's nothing in the diagram that would match this. So C can't be f of x. And you can repeat that logic for graph B. Actually, if you did graph B, and you said, well, maybe B equals f of x, you would get C as the derivative of B, but then you would get this graph again as the derivative of C, and that does not equal A. So neither B nor C could be f of x.